Hi, I am Kushmal and my roll number is 1910110213. So this is regarding math and SEM assessment, and we'll be solving question number 3. So let's get started. So the question says, find the motion of the mass spring system modeled by the ODE and the initial conditions. So the differential equation is y double dash plus 25y is equal to 24 sin t, and the conditions are y0 is equal to 1 and y dash 0 is equal to also 1. And also we have to sketch the graph of the solution curve. In addition, sketch or graph the curve of y is equal to yp, which will be the particular solution, to see when the system practically reaches the steady state. Okay, so we will be solving yp using method of undetermined coefficients. So it's a second order ODE, so its solution can be written as y is equal to yh plus yp, where yh is the solution of the homogeneous part and yp is the particular solution. So first we will be solving yh. So the general so the equation is y double dash plus 25y is equal to 0. So the general equation is y double dash plus ay dash plus by is equal to 0. It's the general equation. Here we can see a is equal to 0 because y dash doesn't exist in the equation. So a is equal to 0 and b is equal to 25. So first we need to find its characteristic or auxiliary equation, as it is said. So it is of the form lambda square plus a lambda plus b is equal to 0. So as substituting a and b, it will be lambda square plus 25 is equal to 0. So lambda is equal to plus minus 5 iota. So it is of complex form. So when it is of complex form, so the solution is also complex. So the solution is of the form e to the power minus ax by 2 plus I omega and e to the power minus ax by 2 minus iw, not omega, it's w. So we will find w first. So w is equal to half under root 4b minus a square. So substituting the value of a and b over here, half under root 4 into 25 minus 0, so it will be half into 10, which will be equal to 5. So we have found w. Now okay, so now we know that yh is the superposition of two solutions. So it will be y1 is equal to e to the power minus ax by 2 cos omega t, and y2 is equal to e to the power minus ax by 2 sin omega t. So on substituting value of a and w in this, so y1 will be cos 5t and y2 will be sin 5t. Okay, so let's start the page. So as we know, yh is ay1. It's a superposition of two solutions, as I said earlier. So it will be ay1 plus by2, where a and b are just constants and are real numbers. So we will just put y1 and y2, which we found earlier. So y1 is cos 5t and y2 is sin 5t. So yh is a cos 5t plus b sin 5t. So it's yh. Now we will find yp, which is the particular solution. So let's find yp. So yp, the particular solution is of the form c1 cos t plus c2 sin t. So differentiating it with respect to time, it will be y dash p is equal to minus c1 sin t plus c2 cos t. differentiating again with respect to time, it will be minus c1 cos t minus c2 sin t. So solving it, it will be like minus 1 into yp. So here we have found a relation which is very important. Y double dash p is equal to y minus yp. So now our equation was y double dash plus 25y is equal to 24 sin t. So you will write y double dash plus 25y is equal to 24 sin t. So when y is equal to yp, you will substitute it with yp. Simple. So it will be yp double dash plus 25 yp is equal to 24 sin t. And now we have found earlier that y double dash p is minus yp, so we will substitute it. So minus yp plus 25 yp is equal to 24 sin t. Further solving it, 24 yp is equal to 24 sin t, and it gets cancelled. So yp is equal to sin t. This is a very important relation which we have found out. So comparing this with this, we have found that c1 is equal to 0 and c2 is equal to 1. So the final solution, which is y is equal to yh plus yp. So yh, which we have found out here, is a cos 5t plus b sin 5t, and yp sin t plus sin t. So this is y. So this is our general solution. So now we have been given some initial conditions like y0 is equal to 1 and y dash 0 is equal to also 1. So we will use them to find the constants a and b. So first you will write the conditions. Y0 is equal to 1, y dash 0 is also 1. Wait a second. Okay, so we will just solve it. So y0 is equal to 1 is equal to a cos 0 plus b sin 0 plus sin 0. Sin 0 is 0, so cos 0 is 1. So here you will get a is equal to 1, our first thing. Now you will find b. So you will first differentiate it. So y dash is equal to minus 5. A is 1, so we will just put it minus 5 sin 5t plus 5b cos 5t plus cos t. So we will put again y dash 0 is equal to 1. So y dash 0 is equal to 1 is equal to minus 5 sin 0 plus 5b cos 0 plus cos 0. So here you will get 1 is equal to 5b plus 1. So 1 gets cancelled. So b turns out to be 0. So we have found a and b. So we'll put both of these here. So we will find the general equation after using the initial conditions. So a cos a is 1, b is 0. Okay. So y is equal to cos 5t, b is 0, so it will get cancelled, plus sin t. So we have found the answer of the first part. So now let's draw the graph for this particular solution, cos 5t plus sin t. So let's draw it. So it's time and it's y which is increasing. It will be 1, 2, and it's visible, minus 1, minus 2. So it will be of the form like this. and the maximum value is 2 here. So it's this is a complete cycle for this function cos 5t plus sin t. Okay, so as you can see, the max value is 2 here, and this is the required graph for cos 5t plus sin t. Amplitude maximum is 2 and minus 2. It's this wrong a little bit. Yes. So this is it, and now we will sketch the graph of y is equal to yp. So as we know, yp is sin t. So let's draw it. It's t over here. It's yp over here. 1 minus 1, and the simple graph of sine function like this. So it's a yp is equal to sin t. Now let's find out the graph of y minus yp. So y minus yp, y is this and yp is this, so subtracting this, it will be only cos 5t. So let's find out how it looks. T y minus yp, sorry, and it's cos 5t. So basically its frequency is increased by a factor of 5, so it will be a squeezed graph because its frequency is increased because of 5, it's cos 5t. Okay, so these are the graphs. This is how the function y is equal to cos 5t plus sin t. It's kind of like a roller coaster, and that's it. And yp is sin t, simple sine function graph, and y minus yp, it is cos 5t, so it is a little bit squeezed because its frequency is increased. So these are the graphs, and this is the solution. So that's it. Thank you.